In this video, we will discuss some questions from IGCSE and O levels related to the topic of turning effect of forces, that is equilibrium. So, in order to start discussing the question, first we will discuss some fundamental requirement. The video related to equilibrium is already uploaded, and the link will also be shared in the description box. So, let us start with the conditions required for the body to be in equilibrium. Okay, for the body to be in equilibrium, there should be no resultant force acting on the body. It means body will not accelerate. So here the forces are shown. Four forces are acting on a body. F2 is acting along positive x-axis. F1 is acting along negative x-axis. F3 positive y-axis. F4 negative y-axis. If the magnitude of the two forces like F3 is equal to F4 and F2 is equal to F1, the resultant force acting on the body will be 0 and it will not accelerate. So F is equal to ma will be 0. So resultant of F1 plus F2 plus F3 will be 0 here minus F1 because F1 is along negative x-axis plus F2 is 0. In the same way F3 positive y-axis plus F4 that is minus F4 along negative y-axis is 0. So if the resultant force is 0, the body will be in equilibrium. In the same way, we can say total upward force is equal to total downward force. In the same way, total rightward force is equal to total leftward force. But beside this, the body should have one more condition to be in equilibrium, because even if the forces acting on the body are equal, if they don't have the same line of action, body may rotate. So rotation is caused by a force and we call it turning effect of a force. So the definition, that is moment is equal to force into perpendicular distance from the pivot. Pivot is the axis of rotation. So moment is equal to F into D unit Newton meter, and moment can be either clockwise or anti-clockwise depending on in which direction the body tends to rotate. So here the spanner is being rotated by a person's hand. The force is applied and the angle between force applied by the person and the difference is 90 degree. So in this case the turning effect will be maximum. If the force and D are parallel to each other, the turning effect will be 0. And if there is any other angle like 30, 60, etc., the body will be having turning effect, but that will be less than the case in which the force is at 90 degree to the distance, that is perpendicular distance. In the same way, we need to recall the definition of center of gravity, the point where entire weight of the body appears to be acting. And center of gravity of the symmetrical shaped body is usually at the center of the body. Like here, the rod, the circle, and the triangle are shown, and their center of gravity will lie in the middle of the body. And sometimes we call it center of mass, but the definition of course of center mass is a bit different. But in case of center of mass, what do we say? The more concentration of the mass is present at that point. If suspended, a body will come to rest with its center of gravity directly below the point of suspension. So here, the weight acting on the body and the point of suspension are exactly in one line. But in the figure B, they are not in line, so they will produce turning effect. The tension in the cord and the weight, they will produce turning effect, and they will bring the body to be in equilibrium. And the second condition of equilibrium, first condition, resultant force should be 0. Second condition, the total clockwise moment should be equal to total anti-clockwise moment. So W1 into D1 will be equal to W into D2 if the force ruler is balanced. So this is the second condition, that is resultant moment is 0. If clockwise moment is equal to anti-clockwise moment, so the turning effect will be 0, body will be in equilibrium. So for the body to be in equilibrium, the two conditions should be satisfied. Now let us start with the questions which are to be discussed. Three questions are taken from GCE O-level 5054 and rest of the questions are from IGCSE. So first question is from variant 21 May June 2013. Here the pattern is shown and it is used to investigate the turning effect of a force. So here the weight is acting and mass is suspended. 4 Newton weight is suspended at one end and its distance from the pivot. Pivot, the axis of rotation where the body is supported, that distance is 40 centimeter and the Newton meter is hung at a distance of 20 centimeter from the pivot. But these two will cause moment in different direction. 4 Newton weight will cause moment in anti-clockwise direction, whereas the Newton meter will tend to rotate the meter rule in the clockwise direction. And it's a uniform meter rule. That means the center of gravity will lie in the middle. Let us see the question, detail of the question. Is freely pivoted at its center, that is at 50 centimeter mark. The position where center of this ruler is pivoted, that is at the center of gravity. So let us draw the point where the center of gravity is lying. So this is CG, center of gravity, and it is 50 centimeter. This distance is 40 centimeters. State the principle of moments for a body in equilibrium. So, what is the statement? Sum of clockwise moment, sum of, here I am writing clockwise moment about a point. There can be more than one moment about a point in one direction. There will be two clockwise moment, one anti-clockwise moment. Body has to be in equilibrium. Sum of clockwise moment about a point is equal to sum of anti-clockwise moment about the same point, ACW, about the same point, same pivot. It means for this to be in equilibrium, moment caused by 4 Newton weight should be equal to the moment caused by Newton meter. So what will be the reading on the Newton meter? We will have to apply the principle of moment for that purpose. So uh, we may call it W1, W1 into 40 centimeter. Its distance from the pivot is 40 is equal to tension in the Newton meter. Force in the Newton meter, we may call it F into, and that distance is 20 centimeter. It's not necessary to convert centimeter into meter here because we have both the quantities in centimeter, both distances D1 and D2 are in centimeter. So it's not necessary to convert. So W1 is 4 multiplied by 40 divided by 20 equals to F. So this answer is 8 Newton. We have to take care of the number of significant figures. Since 4 Newton weight is written 4.0, so this should also have two significant figures. Now the weight of the meter rule is 1.2 Newton. Calculate the size of the force exerted on the meter rule by the pivot. So here the weight of the meter rule is also to be considered. So let us have a look at the drawing. So the weight is 1.2 Newton, or of course weight will be acting in vertically downward direction. So this is W and this is 1.2 Newton. So what is total downward force? Total downward force is equal to 4 Newton plus 1.2 Newton. Answer is 5.2 Newton. So this is the total downward force acting on the ruler. But the upward force is 8. Total upward force is 8. So it means the first condition is not going to be satisfied because the total upward force is not equal to downward force. So it means the point of pivot will be applying some force and that will equalize the upward force. Total upward force is here 8 Newton. So what is the difference if we check? 8 minus 5.2. So that comes equal to 2.8 Newton. So this will be 2.8 Newton force acting in the downward direction. So that the total resultant force will be 0. So this is 2.8. So now total upward force is equal to total downward force. So this is the answer which is to be written here, that is 2.8 Newton. This is the next question. This is also from 5054 O levels. So variant 21 October November 2020. Here this is the question number 3 in that paper. So figure 3.1 shows a door and an automatic door closer viewed from the above. Okay, so it is the automatic door closer here. So here this is the bar which will be fixed to the wall and it may close the door when it is just given a push. So it means it will be applying some force in this direction. When the door opens and closes, the hinge acts as a pivot. A girl opens the door by exerting force P at the point X. So this is the force applied by the girl at point X. And the perpendicular distance between the point of application of force and the pivot is hinge is 0.72 meters. Hinge is acting as a pivot. So a girl opens the door. The force P is perpendicular to the surface of the door. So here the point X is at a distance of 0.72 meter and along the front of the door from the hinge. The force P is 25 Newton. So if force P is 25 Newton, what will be the answer of the turning effect of the force? So 25 into 0.72. Calculate the moment of P about the hinge. So we know the perpendicular distance and we know the magnitude of the force. So we can solve it. F into D. You can write tau as a symbol of moment. So 25 into 0.72 and that is coming 18 Newton meter. The door rotates about the hinge by 90 degree. It means it does not complete the rotation of 360. The circumference of the circle of radius 0.727 is the, of course, the distance where the force is applied is a radius, um, and the circumference which is completed by that radius due to the rotation of the door is 4.5 meter. So you have to calculate the work done by the force. So this will rotate the body. So this is a circular path taken by the door. When the force is applied, door tends to rotate in this direction about the pivot. And the center circumference of this is 4.5 meter. Radius, the length of the door is acting like it's right like a radius. So, but here the door does not rotate up to 360. This is the angle of complete rotation, and this is the distance of complete rotation, that is 2 pi r. But the distance moved by door is only 90 degree. 90 degree means 1/4 of the rotation, 1/4 of circumference. Circumference 4.5. So work done, force into distance, that in that direction when this rotates, what will be this distance? Equal to, means when this rotates up to 90 degree, this distance is 4.5 divided by 4, and this will be 1.125. So D is 1.125. So what is work done? Force into distance. F multiply by D is equal to 25 multiply 1.125. 1.125. We will round it off later on because the data has two significant figures. So we will have to write our answer up to two significant figures into 25. So that will be 28 joule. So this was the part which I did. That is 4.5 meter is the circumference. So 1/4 of the circumference was 1.125, and work done by the force P 25 into 1.125, that is coming equal to 28 joule. Now this is question number 3, 5.5054, variant 22, October November 2021. So the turning effect of a force is measured by its moment. So here figure, this is question number 8 of that year. So figure 8.1 shows a force F acting on an object at point P. Okay, the object is free to rotate about an axis at X that is perpendicular to the page. So the axis is perpendicular to the page and the force is acting at point P. Let us see what is asked. Write down an expression for the moment of F about the axis at X. Draw on figure 8.1 to show what is meant by any other term used in this in your expression. So the expression is what? Force into perpendicular distance. I will be writing your answer here. So here force, moment, you may write torque or simply word moment, is equal to force into, here I will write D, perpendicular distance. So perpendicular distance, how will we show? The force is already extended. This is the line of action of the force. Okay, so what will be the perpendicular distance? Is this the distance? No, the distance is not perpendicular. Okay, so it means this is not the right path, right distance I have taken here. What will be the right distance? This. So this is at 90 degree to this. So force into perpendicular distance. Let us go to the other part of the question. State the principle of moment. This was already written in the previous part. That is, sum of clockwise moment about a point is equal to sum of anti-clockwise moment about the same point. Now here you have to describe an experiment to verify the principle of moment. Include a diagram to help the description. Let us see if it is included in this. So demonstration of the apparatus. So you can have a meter rule and it is pivoted, and we can have one or two masses suspended at one end, and here one mass, heavier mass, is suspended at the other end. So for this to be in equilibrium, F1 into D1 will be equal to F1 into D1, there are two anti-clockwise moments and one clockwise moment. So F1 and F2 are causing anti-clockwise moment, where F3 is causing clockwise. So F1 into D1 is equal to F2 into D2. So we have to take several readings. We can change the weights, we can change the distance. Every time, first we have to find out the center of gravity. What will be the first point? You have to locate the center of gravity by balancing the meter rod first. Before placing the masses, the meter rod has to be balanced. Means this is the meter rod and it is placed on the pivot. After this is balanced perfectly horizontal, the masses are to be suspended, and again the balance has to be adjusted. When this is in this position, in this condition as is shown in the figure, that means this is satisfied. The distances are to be noted down. Suppose this is 70 and this is 50. So what will be the distance? 70 minus 50 is 20. Okay, so distances may vary. So afterwards, we can change the position of F1 and F2. So distance will change, or we can change the values. So for 3 to 4 values for readings, we can show our confirmed result. That is, the sum of clockwise moment about this pivot is equal to sum of anti-clockwise moment about the same pivot. We can have more masses, like instead of suspending here heavy mass, we can have two lighter masses also at two different positions, and we can carry out the investigation. Mm. So describe an experiment to verify the principle of moments. Include a diagram to help the description. So this is done. The diagram was also shown. A worker carries a ladder on his shoulder. His shoulder acts as a pivot. So this is the point where the pivot is present. And his hand is applying one force at point L. One bucket is suspended at the other end. Distance of bucket from the shoulder of the person is 1.3. The ladder is wider at one end than the other end. The mass of the ladder is 8 kilogram. The gravitational field here, it is given 10 Newton per kg. But now this you people are instructed to use 9.8 instead of using 10. So accordingly, because this is the old paper, that is paper before in 2023. So the value of G was taken as 10. So here we will take it accordingly. So what will be the weight of the ladder? That will be W equals to mg. So 8 into 10, that is 80 Newton. So we have to remember it and state what is meant by center of mass. Center of mass, this is the point where the entire weight will be acting, or more concentration of the mass is present. The center of mass of the ladder is not halfway along its length. It means it is not a uniform ladder. If we have uniform meter rule, center of gravity lies at 50 centimeter mark. Uniform meter rule means 100 centimeter long. Meter rule gives us rule gives us two information, that is the length of the ruler is 100 centimeter and the center of gravity lies at 50. In the same way here, it is not halfway, means the mass distribution is not same. It may be heavier at one side than the other. Okay, what it shows about the ladder, the mass is not distributed uniformly. One end is heavier than the other. Is not distributed uniformly. One side is heavier than other. Okay. The center of mass of the ladder is horizontal distance of 0.9 meter from the worker's shoulder. Worker's shoulder is acting like a pivot. So calculate the moment about the worker's shoulder of the weight of the ladder. So weight of the ladder, we can calculate it simply by applying F into D. So what will be F into D? Moment is equal to F into D. So that was 80 into zero point 0.9. So what will be the answer? 80 into 0.9. It will be 72 Newton meter. The bucket of weight 87 Newton is suspended from the ladder at a horizontal distance of 1.3 from the worker's shoulder. So its distance, perpendicular distance is 1.3 meter. The worker keeps the ladder horizontal by exerting a vertical force at point L. L is a horizontal distance of 0.5 meter from his shoulder. Determine the size and direction of L. Let us see the figure. This thing. Okay, so L is the center of mass where weight is acting, and the person is applying an upward force at this point. Okay, and the distance of this force is 0.5 force. Weight of the ladder 80 Newton, not 80 Newton. This is uh, 8 kilogram. It was, yes, 80 Newton, and its moment is 72 Newton meter. Okay, and bucket, it is 87 Newton. Bucket is causing anti-clockwise movement. Weight is causing clockwise movement about the pivot. So this is the pivot P. Okay, and the force applied by person's hand is upward, and that is also causing anti-clockwise. Meaning we have two anti-clockwise moments and one clockwise moment. So we have to find out the force applied by the person. It means we have to, I'm solving it here instead of solving at the place which is space provided by the examiner in the paper, because the figure is here. So here, uh, total anti-clockwise moment is equal to clockwise moment. Okay, so here this is 87 into 1.3, distance of 87, bucket is 1.3 from the pivot, plus they are added anti-clockwise moments, L into, the force is not known to us, we have to work it out, 0.54 is equal to clockwise moment. Clockwise moment, we have already calculated it, 80 into 0.9 is 72. So 87 into 1.3. Here, the ladder, the weight of this is, let me check once again. I have forgotten the value of this weight of bucket. It's no, it's right. It is 87. Means the direction of force applied by the person. If it this is upward, then clockwise moment will be greater. Anti-clockwise moment will be greater. It means the person has to apply the downward force. 87 into 1.3 is 113. So it means that is providing greater moment. Means the person has to apply a downward force to keep this in equilibrium. Because if he applies the upward force, the force applied by person will also exert an anti-clockwise moment, and the anti-clockwise moment will be greater. But in order to keep it in equilibrium, because the weight is 80 and its distance is also smaller, 0.9 meters, so its moment is only 7.2, whereas the moment of bucket about the pivot is 113, means the force is to be downward. So it means this part is to be, let me correct it. Here, 87 into 1.3. In the same way, this is not upward, this is downward. This is downward. So it means this will be along with the clockwise moment. Means moment caused by this person, weight of the ladder is 72, plus the moment of the person's hand, L into 0.54. So this is 113.1 minus 72 is equal to L into 0.54. So 113 minus 72 is equal to 41.1. L into 0.54. So what is L? L will be 41.1 over 0.54. 54. That is coming 76. So this is a force which is to be applied by the person in downward direction to keep this in equilibrium. Okay, so that answer is, and size of force, what is the direction? Downward. Okay, size of the force 76 Newton and direction downwards. Okay, you have to write in words, not the arrows. Okay, let me also write it. And the moment caused by it will be, moment caused by the 76 Newton is in anti-clockwise. Sorry, clockwise, because the weight is also acting in that direction. So now we have questions from IGCSE. A rock climber, and this is variant 41, October, November 2022. Total mass of 62 kg. Holds herself in in horizontal equilibrium against the vertical cliff. She pulls a rope that is fixed at the top of the cliff and presses her feet against the cliff, as shown in the figure. Calculate the total weight of the climber. If you take G equals to 10, that will come 620 Newton. And state two conditions needed for the equilibrium. That is, resultant force should be 0 and total clockwise moment will be equal to anti-clockwise moment. So here 62 into 10 equals to 620 Newton. According to new pattern, what it will be? 62 into 9.8. So that will come 607.6. Means 608 Newton. If you want to express this in two significant figure, it will be 61 Newton. 610 Newton. If you want to express it in two significant figures. State two conditions are needed for the equilibrium. One is what? Resultant force should be 0. Sum. This sign is sigma. Sum. You may write in words. The sum of the forces acting on the body should be 0. This is the first condition. Second condition, resultant moment. Here again, I'm using the symbol. It will be 0. Tau represents moment. So total clockwise moment should be equal to total anti-clockwise moment. The climber's center of mass is 0.9 meter from the cliff. So center of mass is at this point, which is labeled here, and it's 0.9 meter from the cliff. So weight is acting at the center of the mass. Calculate the moment due to her weight. So there will be two possible answers. One was the weight 620 Newton, and when we used G equals to 9.8, the weight was 610. So if we take 610, force into perpendicular distance, 610 into 0.9, 549 Newton meter. And using G equals to 10, this weight is 620. So 620 into, because this is from the paper before 23, so we may use G equals to 10. So 620 into 0.9, it will be 558 Newton. 558 Newton meter. This is the moment of the weight. The line of the rope meets the horizontal line through her center of mass at a distance of 1.2 meter from the cliff, as shown in figure. Let us go and have a look at the figure once again. Let us read the question. The line of the rope meets the horizontal line through her center of mass at a distance of 1.2 meter from the cliff. So this is the line where the rope is meeting. Okay, so horizontal line is there. So this is the point where the line of action of tension force in the rope is acting. So that distance is 1.2. The line of rope meets the horizontal. This is done. The rope is at an angle of 60 degree to the horizontal. Determine the tension in the rope. So here the figure is drawn for you, and working is also done. So this is T, and because T is not making 90 degree with this distance 1.2, so we have to take the component of T which is perpendicular to the distance. So when we resolve T into two components, this is T sine theta and the other one is T cos theta. Why we ignore T cos theta? Because T cos theta is parallel to the distance 1.2. Its moment is 0. T cos theta, no moment, as it is parallel or anti-parallel to distance. It is along the line. No moment. So we will not take this. Which distance, which component of force, tension force we will take? T sine theta. Sine is 60. Okay. So T sine 60 and its distance is 1.2. So this is causing anti-clockwise moment, and the weight of the climber about the pivot. The distance is 0.9. The feet are to be taken as a pivot. So that is causing clockwise moment. Okay, so this part is already solved. We may solve it again also. T sine cos 60 into what is the perpendicular distance? 1.2 into 1.2 is equal to W into 0.9, and that is 558. I am taking the one which was multiplied by G equal to 10. So we can calculate tension. Sine 60 is 0.86, 866. So this can be solved. Uh, and let us check the answer of this. I will be solving here at this point. T sine 60 into 1.2 equals to 558. So sine 60 into 0.866, sine 60 t into 0.866 into 1.2 equal to 558. Into 1.2 is 1.04. T into 1.04 equal to 558. So what is T? T will be 558 over 1.04. So 536.5 means 537. So three significant figure means 537 Newton is the tension in the rope. Next question number 5, 0.0625, variant 42. This is February March paper 2017. This is an stationary object which is acted upon by a number of forces. State the condition which must be true if the object does not accelerate. Means resultant force should be 0. Does not rotate, resultant moment should be 0. Okay, so this is the same condition which we have been writing in previous answers. Here delta F is to be 0, and here resultant moment. It means total clockwise moment is equal to total anti-clockwise moment. Okay, anti-clockwise moment is equal to clockwise moment, or clockwise moment equals to anti-clockwise moment. Let us have a look at the figure. This is question number 2 of that paper. So this is a boat which has a weight of about 24 kilonewton, and one rope is it's being lifted up by means of two ropes. So the tension, and it is in stationary, means it is in equilibrium, and the conditions are satisfied. Means total upward force will be equal to total downward force. In the same way, moment is also to be 0. T2 is acting at P at a distance of 0.4 meter, and T1 is acting at a distance of 1.2 meter from the center of gravity of the boat. Not to scale means this cannot be done by measurement. They are the values are just written. They are not according to the measurement. The weight of the boat is 24 kilonewton. The tension in the ropes are T1 and T2. Determine the moment of the weight about P. P is to be taken as a pivot where T2 is acting. What is the advantage of taking P as 0 as a pivot? So that the moment caused by T2 will be 0. Why moment caused by T2 will be 0? Because it is acting at the pivot. So we can easily find out T1 later on. But here in the first part, we have to find out the moment caused by 24 kilonewton weight of the boat about P. So what does 24 kilonewton means? Torque is equal to F into D, and this is 24,000 into 0.4. 24,000 into 0.4. The answer is 9600 Newton meter. If it is in equilibrium, since T1 is acting at the pivot, its moment can be ignored. But T2's moment is to be considered. Let us see what is asked in the other part. 9,600 is to be remembered. This will be used in the other part. Tension in T1. T1, because T2's tension, T2 right now when we take P as a pivot, and T2 is having same line of action passing through pivot, so its moment will be 0. Moment of T2 will be 0, so it will not be in the equation. So anti-clockwise moment is caused by the weight. Weight is causing anti-clockwise movement about P, and T1 is causing clockwise movement about P. So we can solve it here. T1, what is the distance of T1 from this? From pivot, we have to add these two. 1.2 plus 0.4 means 1.6 equals to moment caused by the weight. Okay, so that was already calculated, and that is 9600. Okay, so T1 equals to 9600 divided by 1.6. That is coming 6000. So tension in that rope is T1 is 6000 Newton. And what is the moment value of T2? We can find it out by applying first condition of equilibrium. Tension in T1 is already calculated. That was 9600. And tension in T2. So here, instead of, we can do by applying the method of principle of moment also, but since this is passing through this P, then we will have to choose another point as a pivot. So then T1, we can take the point where the T1 is acting. That point is to be taken as a pivot, and we can take now T2, or we can apply first condition of equilibrium. If we take this point as a pivot, then W is 24. This distance will be 2400 into 1.2 is equal to T2. What is the distance of T2? 1.6. So we can calculate T2 using this. So 24 into, let me write the value of T1, 6000 Newton. Okay, so 2400 into 1.2. This is 2880 equal to, I'm taking it in the denominator, T2. So what is T2 equal to? Divided by 1.6, and that is 1800. So T2 is 1800 Newton. And let us solve it by the other method. Okay, I have made a mistake here. This is 24,000, sorry. So this will be having one more zero, and this will be 18,000 Newton. Okay, this is 18,000 Newton and 6,000 Newton. So if we apply total upward force equal to total downward force to find out T2, this will also give us the same answer. Total upward force is equal to total downward force. So downward force is 2400 kilonewton, means 24000. And T1 we worked out 6000 plus T2. So what is T2? 24,000 minus 6,000, that is 18,000. 18,000 Newton. So both the ways will give you same answer. Either you take P, this one as a pivot, and take moment about this point, So now C is causing clockwise, weight is causing clockwise, and T2 is causing anti-clockwise moment. So this gives 18,000 Newton, or you apply total upward force is equal to total downward force. That is also giving us the same answer. Now the next question, this is from October number 2020, variant 42. Define the moment of a force about a point. How do we define? That is force into perpendicular distance. Okay, turning effect of the force, and that is equal to force into perpendicular distance. F into D. I am writing in symbolic form. Figure shows a uniform rod of wood suspended from a pivot, and the weight is W, and pivot is here at this end, center of mass W, and the force is applied here. The mass is held stationary by horizontal force acting as shown. So this is the horizontal force which is acting, and the mass is held stationary in this position. What is the angle of this with the pivot here? Vertical between the rod and the vertical is 34. The mass of the rod is 0.080 kilogram. Calculate the weight W of the rod. So if we consider G equals to 10, that will be 0.8 Newton. W is equal to mg. So 0.08 into 10, it will be 0.8 Newton. Otherwise, if we use 0.080 into 9.8, it will be slightly smaller. So 0.08 into 9.8, 0.784 Newton. Moment of W about the pivot. What is the perpendicular distance of W about the pivot? This distance is to be taken, this one. This is the line of action of W. So distance is 0.25. So W is, you can take either 0.8 Newton if you use 9.10, G equals to 10. So moment will be 0.8 0 into 0.25 means point 0.8 into 0.25, it gives us 0.2 Newton meter. And using 0.784, if G is 9.8, 0.784 into 0.25, that is giving us 0.196 Newton meter. Now moment of W about the pivot is worked out, 0.2 Newton into meter or 0.196 Newton into meter. The moment of F about the pivot. So moment of F will also be the same as that of moment of W because this is in equilibrium. So moment of F is also 0.196 or 0. 2. So we have to calculate the weight. Sorry, force. So this is 0.2 Newton meter or 0.196. So here the moment is equal to the moment of F will be equal to the same moment, that is moment of weight. So we have to calculate the value of F here. So what is the distance of F? We will have to have a look at the distance. Anyhow, F into D is equal to 0.2 or 0.196. Well, this is 0.75. The weight, this force is acting at a distance of 0. This is the perpendicular distance between this. So I will solve it here at this point. So this is the line of action of F, and this is the perpendicular distance from the pivot. Okay, so F into 0.75 equals to 0.2 or 0.196. So what is F? 0.2 divided by 0.75. So 0.2 into, sorry, 0.2 divided by 0.75. That is 0.267 Newton. The answer will be slightly different if we take 0.196 as a moment. The angle between the rod and the vertical is increased. State whether the force F needed to hold the rod stationary must be increased, decreased, or stay the same. Explain your answer. So in order to understand this, when this is moved, angle is increased, means the rod is to be in this position like this. So when the rod will be in this position, F is this. Now the perpendicular distance is decreased. So now F is smaller. Earlier F was 0.75 meter. So in order to keep the same moment and in order to keep the rod in equilibrium, the force has to increase because the perpendicular distance due to the rotation has decreased. Let me show you the rotation here. See, this is the rod angle with the vertical is 0.34 meter, and this is the force which is acting. This is the angle with the vertical 0.43, sorry, 34 degrees is the angle. So when the rod is rotated, so that the angle with the vertical is increased, means this distance 0.75 meter now will be less. This is the new position, and this is the vertical distance. This is the perpendicular distance between F and this. D is smaller means F has to be greater to provide the same moment. So this angle has increased. Angle with the vertical is now increased. So this is of 2 marks. So 2 points are to be there. What are the 2 points? That is the uh, distance, perpendicular distance decreases as the angle with the vertical is increased. So to keep the same moment, the force has to increase. F into D is the moment. Now, this is another question number 7, 0.0625, 0625, variant 43, October, November 2016. So, two mechanics, A and B, are trying to use a two-person spanner wrench to loosen a nut on a large wheel. So this is the large wheel and two people are using it. So one person mechanic A is applying force of 500 Newton, another mechanic is applying force of 400 Newton. Distance of the two mechanics from the pivot is same, that is 1.2, 1.2. Since the two people are applying different force, so their moments will be different. One will be anti-clockwise moment, the other one will be clockwise. Mechanic B is applying clockwise moment about P, whereas the mechanic A is applying anti-clockwise moment about P. So mechanic A exerts this force and B is exerting 400 Newton. Calculate the magnitude and direction of the resultant moment exerted by the mechanics on the nut P. So what will be the resultant moment? So it means since one is clockwise and the other one is anti-clockwise, so resultant moment has to be calculated by what? 500 into 1.2. How much it is? 500 into 1.2, that is 600 Newton meter. And what about the mechanic B? 400 into 1.2, 480 Newton meter. So one is clockwise and the other one is anti-clockwise moment. So what will we do? We will subtract. One moment was 600 and the other one was 80, 480. 400 into this. So what is the answer? 120. This is, and in which direction? Whose moment is greater? The mechanic A, because he is applying greater force. So it will be in anti-clockwise. Now mechanic B reverses the direction of 400 Newton force he exerts on the spanner, and mechanic A continues exerting 500 Newton in the downward direction. Now mechanic A also exerts the force in the upward direction. Sorry, he exerts force in upward direction and he exerts force in downward direction. What does that mean? This force is now having this direction. Now, this is also causing anti-clockwise. This is also anti-clockwise. Now, the two moments are added. So, what will be the total moment? Now, 600 was caused by mechanic A, and now this will be added. Now it's not subtracted because the direction of moment is anti-clockwise direction. That is 480. So what will be the answer? So in order to show your answer in two significant figures, we can write 1100 Newton meter. This is the resultant moment of this answer, which was asked in the next part. What was the part? This part. When they reverse it, this mechanic B reverses the direction. Okay. So resultant moment is 1100 Newton meter or 1080. Magnitude of the resultant force now exerted by the mechanic on the spanner. Now mechanic one is upward and the other one is downward. So 400 is upward and 500 is downward. This is now upward and this is downward. So 500 minus 400. Why minus? Because the direction of force is opposite to each other. So resultant force is 100 Newton. Now this is another question 0625 IGCSE 42 variant October November 2019. Two conditions for the body to be in equilibrium, as we have been discussing it several times. Resultant force should be 0 and resultant moment should be 0. Total upward force or sum of the forces acting on the body should be 0 and sum of the moments, that is total clockwise moment, will be equal to total anti-clockwise moment. This is the condition 2. Now here this is the diagram which shows uniform meter rule. Uniform meter rule means center of gravity is acting at center, that is 50 centimeter mark. Okay, so the distance PQ is 100 centimeter. The mass of meter rule is 0.12 kg and its weight is W. So W is to be found out. Draw the and label an arrow to show the force W, an arrow to show the force R acting on PQ at the pivot, and by taking the moment about the pivot, calculate F. So this is W and this will be 1.2 Newton because I'm taking G equals to 10 Newton per kg. As this was the paper of 2019. If we take 9.8, then 0.12 mass into 9.8 is 1.176. 1.176 Newton. In order to keep answer in two significant figure, this will be also rounded off and this will be 1.2. Okay, now arrow to show the force R acting on PQ at the pivot. So pivot will be applying an upward force here. This is R. Now we have to see which forces are causing. We have to calculate the force F. Means we have to check how many forces are causing clockwise moment and how many are causing anti-clockwise moment. So 0.5 Newton, this is the weight which is hanging. This will rotate the rod about the pivot in this direction and this is anti-clockwise. Okay. And what is W? W is called rotating in this direction. This is clockwise. What about F? F is rotating it in this direction. It means helping 0.5 Newton force. That is same moment anti-clockwise. So two anti-clockwise moment and one clockwise moment. What is the distance of W from the pivot? That is 0.4 meter or 40 centimeter. This is 10 centimeter. And what is this distance of F? This is to be known. Since this is uniform rod, so this distance will be 50. So 50 plus 40 is 90. F is acting at a distance of 19 centimeter from the pivot. So total anti-clockwise moment is equal to total clockwise moment. So anti-clockwise moment 0.5 into 10. I'm not changing centimeter into meter because all distances are in centimeter. Plus this moment of F is also added to it. F into 90 centimeter. Distance of F is 90 equal to clockwise moment. What is the distance of W? 40 and I am taking it 1.2 here. And this is 40 centimeter. So this is 0.5 into 10 is 5 minus I am multiplying this and writing it here to this side. So 1.2 into 40 gives me 48. Instead of taking it to this side, I am changing this style. Okay, 5 plus F90. I will keep F here equal to 48. So F90, F is equal to F90 is equal to 48 when this side goes to the other side minus 5. Okay, so this is 48 minus 5 is 43 and F is equal to 43 divided by 90. So 43 divided by 90 gives me 0.477. So means 0.48 Newton. So this is the force which F is exerting on this. And what will be value of R? It is an upward force. So total upward force will be equal to total downward force. So what we will do in this, we have to remember the value of F, 0.48 Newton. Okay, and the weight is 1.2 Newton. Calculate R. So what is R? That is R plus F. F is upward force. R is also upward force. R plus F is equal to 0.5 plus 1.2. R plus F is equal to total upward force is equal to total downward force 0.5 plus 1.2. R is to be worked out. This is 0.48 is equal to 1.7. So R is 1.7 minus 0.48. 48. So 1.7 minus 0.48 gives me 1.22 Newton. In two significant figures, this will be simply 1.2 Newton. So this was our last question. So we will discuss rest of the questions later on. So we'll see each other with the other video, inshallah. Allah Hafiz.